Welcome to clickmyproject.com.
Let me discuss about the process on the performance of EEG signals for biometric recognition.
Let me discuss about the abstract of the project. The electroencephalogram is a recording of the electrical activity of the brain from the scalp. The recorded waveforms reflect the cortical electrical activity. EEG measures voltage fluctuation resulting from ionic current within neurons of the brain. Small metal discs, usually made of stainless steel, tin, gold or silver covered with a silver chloride coating. They are placed on the scalp in special positions. These positions are specified using the International 10-20 systems. It acts as a malleable extension of the electrode so that the movement of electrodes capable is less likely to produce artifacts. Electroencephalogram, wherein the strokes are directly detected and the brain signal is recognized. Here features has been extracted from the pre-processed signal and performed classification followed by fusion strategies. Re-referencing the signal to common average reference consists in subtracting to each sample the average value of the samples of all electrodes at this time. The autoregressive model specifies that the output variable depends linearly on its own previous values and on stochastic term. Thus, the model is in the form of stochastic difference equation. Power spectral density is a measure of a signal's power intensity in the frequency domain. In practice, the PSD is computed from the FFT spectrum of a signal. The feature sets are extracted from multiple data sources can be fused to create a new feature set of represent the individual score level fusion and decision level fusion are derived based on the above mentioned fusion. Let me discuss about the flow diagram for our process. Initially, the input signal has been generated. Here, EEG signal need to be generated for processing and analyzing. Read input signal with the represented format. A typical EEG signal depicts the series of waveforms which occur in a respective order, and the database has been used where the huge amount of signals are stored. And in the pre-processing, here common average reference filter are used. The re-referencing the signal to common average reference consists in subtracting to each sample the average value of the samples of all electrodes at this time. CAR is commonly used in EEG, where it is necessary to identify small signal sources in very noisy recordings. And in the feature extraction part, there are three feature extraction methods are used. One is AR model, that is autoregressive models. The autoregressive model specifies that the output variable depends nearly on its own previous values and on a stochastic term. And in the power spectral density, that is PSD, is a measure of a signal's power intensity in the frequency domain. Practice, the PSD is computed from the FFT spectrum of a signal. PSD provides a useful way to characterize the amplitude versus frequency content of a random signal. And in the spectral coherence features, the spectral coherence is a statistic that can be used to examine the relation between two signals or datasets. It is commonly used to estimate the power transfer between input and output of a linear system. Next, in the classification stage, Manhattan distance are used. Manhattan is one type of distance estimation which is used for evaluating the similarity of a given recognition sample. And in the Euclidean distance between two points in Euclidean space are also used. In the cosine distance calculation, the cosine similarity between two vectors is a measure that calculates the cosine of the angle between them. And finally, the fusion strategies are proposed. In the fusion strategies, here feature level fusions are used. Fusion of the available information can be performed by first evaluating the main vector representing the entire recognition samples, And in the score level fusion, this fusion can be performed once each recognition frame is compared with the enrollment data of a user. And finally, the decision level fusion. This fusion is performed estimating a potential identity. Finally, the performance has been analyzed. Here, analyze the entire performance by implementing the EC resting state protocol and EO resting state protocol. Let me discuss about the running procedure for our process. Select the main file.dump file in the current folder, right click the file and run for executing this process. This is the main window of our on the permanence of EEG signals for biometric recognition. By pressing the input EEG signal button, we can browse the EEG signal from the dataset folder. And here I display the input EEG signal in waveform format, and here EEG data are displayed in a table format. By pressing the pre-processing button, we can perform the CAR operation, that is common average referencing filter, and this is the pre-processed data. By pressing the next button, we can move on to the next window. Here there are three feature extraction algorithm are used. By selecting the AR model, we can extracting the auto-regressive features, and by selecting the power spectral density, we can estimate the power spectral density of our input signal. And by pressing the coherence, we can extract the coherence features, that is spectral coherence features of our input EEG signal. And then in the enrollment process, we combine the entire data set features values. Here I displayed in a train features table, and by pressing the classifier button, we can perform any one classifier among three classifier. By selecting the Manhattan distance, we can calculate the Manhattan distance, and then equivalent distance. Here also we perform the equivalent distance of our features and also the train features. And by pressing the cosine function, we perform the cosine distance estimation. And finally, the fusion strategies has been performed. Here three fusion types are performed. In the feature level fusion, features are combined and fused. Here the result of the classifiers are shown in the text box. And in the score level fusion, we perform the score level, that is operations of the fusion strategies. And in the decision level fusion, we perform the potential intensity fusion strategies. Here also the output of the classifier results are displayed in the edit box window. And by pressing the rank 1 IR analysis button, we can perform the analysis graph. And here there are EC resting state acquisition protocol and also EO resting state acquisition protocol for our feature level fusion, score level fusion, decision level fusions are performed. And this is the feature level fusion. Here perform EC resting state acquisition protocol and also EO resting state acquisition protocol for our AR, PSD and also coherence features. And this is the score level fusions process for our EC resting state acquisition protocol and also EO resting state acquisition protocol result. And this is the decision level fusion analysis graph. And this is the decision level fusion by combining only the L1 distance. Finally, we analyze the EEG signal strategies. Thank you.